We're trying to get you thinking, well, what if I did make some changes? Could I get off of medicine? Could I actually reverse the diabetes that I've been diagnosed with? I've seen it happen many times. These people not only have reversed diabetes, they've reversed high blood pressure. They have improved their kidney disease from stage 3, GFRs of 45, to greater than 60, which is in the normal range. There are only 3 or 4 people in here, and they're happy. But the people who were particularly ecstatic, it was my partner's erectile dysfunction cleared after 6 months. Why did that happen? It's because eating this way unclogs arteries. It's been demonstrated not only by the study at the Cleveland Clinic, but by Dean Ornish at another study. 2 documented studies in the world literature that demonstrate reversal of that atherosclerotic change by changing what you eat. Now, Ornish's study went a little further. He not only changed what people ate, but he also put them in yoga and meditation and exercise them 3 times a week. And he put them in group therapy to love more and hate less. And so they were really like, okay, he took over their lives. And they had greater improvement, like about 86% unclogging their coronary arteries, compared to Esselstyn's group at the Cleveland Clinic, which had about 35% unclogging. So the more lifestyle changes that you incorporate, the healthier you'll be in the long run. And what are those 6 pillars of lifestyle? Anybody? Number 1, 2, 3. What? What is it? Stress is one. So how we deal with stress is extremely important. And when I find someone who is so stressed out, they have a poor relationship with their significant other, they have a child that's in prison, they have some kind of issue. Talking to them about helping them change the food issue doesn't go very far. We need to help that person deal with their stress first. And so that's why this is an individual kind of thing, but in classroom settings, these 6 pillars: stress, what else? Sleep. Sleep is another one. I didn't realize it was so important until I became board certified in lifestyle medicine last year. As I was studying, I learned the importance of sleep and how it can decrease your life expectancy. What's another one? We have 4 more. Connection. Social connection. Sitting at home being lonely, anxious, and depressed is not a healthy way to lead one's life. And so social connection is definitely important. We've gone 3. What else? What's that? Physical activity. Physical activity. How much will you move? If we're couch potatoes, it's going to be a lesser life. And then now we have 2 more. What else? Risky substances like smoking and alcohol. But what's the one that's probably one of the most important in anyone's life? The food. It's the food. And it's one of those issues. You know, if you were back in the 60s, people were smoking, doctors were smoking, they were telling their patients, hey, this may be relaxing for you, as they were taking a puff on this Camel cigarette. And so doctors, it took 6 or 7,000 studies to change what they were doing, to finally say, hey, smoking is not healthy for you. So Scott is just about ready here, I think. And so I just want to end by saying food is the new smoking, and just give it a lot of thought. I know it may be hard because there's a lot of barriers to making change, but it can be fun and really life enhancing. And you may be one of these people who's sharing the benefits that you get. So with that,
Sure.
Scott, diabetes.
Talk about diabetes. So the slides they were up there, but we're having some computer glitchy problems. It just wants to run through all the slides, and if they can get them up there, we'll get them up there. But I can just talk also about diabetes and answer questions. We can do more interactive and stuff. But hopefully we'll get the slides up. I have some videos and stuff. But if not, there's the recording of the previous series of 12 classes, the diabetes classes, the exact same slides and everything is on the website. So you can always just go back and watch that particular lecture and see the exact same thing I was going to present tonight. But I want to start off just by talking about also on the website is kind of a good, I wrote an article several years back about diabetes. And if you guys were here for when I showed you the Live Lifestyle Medicine website with the tutorial and where everything's at on there and everything, if you go to the resources page at the top there of the livelifestylemedicine.com website, and then you click on, when you get into the resources page, handouts from classes, that's another one there. And if you click on that and scroll down almost all the way to the bottom of that list, you'll see an article written by me on diabetes. Control versus cure is the title of it. Oh, he's got it. Looks like he's trying to get it up there. And so that article that I wrote is a good summary of everything I'm going to kind of talk about here tonight. So you don't have to, all these details and stuff, you can just read that article and that'll kind of give you a good summary of everything. So, but what I want to talk about with diabetes first, anybody, so you don't have to share your own personal, but how many people in here either have diabetes, pre-diabetes, or know someone with diabetes or pre-diabetes? So pretty much everybody. So it ends up it's half of the population. So half of the population of America, it's over 150 some million, have either diabetes or pre-diabetes. And when it comes to pre-diabetes, I'll define each of these. 90% of people with pre-diabetes don't even know they have pre-diabetes. So it's just pretty much ubiquitous. And so we're going to talk about insulin resistance tonight, because that's essentially what's the cause of diabetes. And we're going to briefly talk about type 1 and some of the other types of diabetes, just to kind of give you a real basic understanding. But 90+% of everything I'm going to be talking about tonight, we're talking about type 2 diabetes and pre-diabetes, and that's caused by insulin resistance, because that's what affects most of us. But we'll start off. I want to say a couple of things about kind of how I got with diabetes. Always wanted to have a specific class for it, because it's something I'm really passionate about, and it was always something that was a big interest area for myself. So 20 years ago, when I've been a PA for 20 years now, and another thing I want to say before I dive into this, just to make sure we cover it. So if you're going to make some big changes with diet and lifestyle, and you have diabetes, for example, make sure you're in contact with your medical provider, because you're on insulin or you're on blood sugar lowering medications, you can make these changes and your blood sugar could drop too low. So you might need to have your insulin dose lowered or some of your medications adjusted to make sure you don't get too low. In the back.
So I have low blood sugars, and
Yeah.
what I noticed when I first started is that it went real low. So I have to kind of keep a schedule.
Yeah. So sometimes people can get too low. And a lot of times if you're not on diabetes medicines or blood sugar lowering medications getting too low is usually because of insulin resistance, which we'll be talking about. Because you can have basically too much insulin, and the insulin can kind of work. Sometimes it works well, and sometimes it doesn't work well, and it can be really unpredictable. So there's that. But for me, diabetes, how I got into it, one of the first jobs I had, I was up in Salem, and there was a community health center there, and really tight budget there and everything. And so we, amongst the providers that were at the clinic, they kind of asked, what area of medicine are you really, besides we're all family medicine, but what areas are your interest areas? And so there were some people that were into women's healthcare, and some that were into rheumatology and orthopedics. And even though we could still refer out to specialists when we needed to, they kind of, for budgetary reasons, say, well, let's try to refer within our own group when we can. And then if it's not something that one of our providers can handle, then we will refer out. And so I volunteered to kind of be the diabetes guy, because that was something I had really done a lot of extra continuing education, went to conferences. I actually went to the Diabetes Educator Conference. I went to American Diabetes Association conferences. I really read a lot of the journals and stuff, because that was just a really passionate interest area for myself. And this is back in 2005, between 2005 and 2008, is when the timeline was on this. And so I was getting all the really challenging patients with diabetes, and the kind of the thought process at the time was get everybody on insulin, get them on all these medications to get the blood sugars normal, because at the time we thought that, well, that makes sense. If we get the blood sugars normal, kind of like somebody that doesn't have diabetes, maybe we could prevent the heart attacks and the strokes and the blindness and the kidney disease and the amputations and the neuropathy and all, the eye symptoms, all the bad stuff that happens just by having diabetes. Maybe we could help with those things if we really treat it aggressively, really get those blood sugars down to basically normal. And so that was kind of the thought process at the time. And during that time, there were these big studies that were being done. One was the VA, done at the VA. Another was the Accord trial. So they had all these big studies that were going to tell us whether or not this was, it was kind of inherently what we thought would happen. But these big studies were going to prove it one way or the other. And so in 2008, actually, I went to the American Diabetes Association National Conference in San Francisco that year. And that was when they were going to release the results of these big trials that they were doing. And so we were all really excited to see what the outcomes were and everything. And what we ended up finding out was it was actually the people that were being treated the most aggressively were actually dying sooner. So they actually, 2 of the 3 trials, they stopped them early because it was killing patients. And so we're like, well, what the heck? And so then there were a little bit of less retinopathy, which is the disease in the eye, that looked a little tiny bit better. So there was a couple things that looked a little bit better, but it was killing people. And so what we in hindsight, what we figured out was that by driving the blood sugars down close to normal with artificial means, with insulin and medications, not really treating the cause, which is insulin resistance, which is what we're going to talk about, you're risking causing problems. And what we realize is in hindsight is that people's blood sugars were getting driven too low, because when you get down to close to normal blood sugars, it's really brittle. You could really get too low, and it was causing a lot of adrenaline release in the body and puts a lot of stress on the body, the heart, everything else. And that's what we, in hindsight, realized is what was happening. So it kind of made me at the time, and a lot of us in the diabetes field, kind of reevaluate. Of course, that was before the GLP-1s and some of these newer drugs, but I think it's going to turn out going to be a similar philosophy, is that, hey, we really need to treat insulin resistance, because that's really the culprit here when we're talking about type diabetes, pre-diabetes. And I'm going to talk about the different kinds of diabetes. I just wanted to give you a little background about how kind of where I was at, and kind of how I became to want to talk to you guys today about diabetes. So any questions about that so far before I get into the types of diabetes? So, all right, so type 1, let's talk about that first. So type 1 is autoimmune diabetes. And so we used to call it diabetes in kids, juvenile onset, we used to call it, because it was most often occurred in younger people. But it can happen, in your teens, in your 20s. It can happen we'll talk about a type 1.5 diabetes is another type that's kind of newer. And so type 1, essentially all you need to remember is that your own immune system attacks the cells in your pancreas that make insulin. So our beta cells in our pancreas make insulin. And so what's happening is your immune system's attacking those cells, destroying them. So you just don't make insulin anymore. So you're going to need insulin injections, or else you'll die, because you have to have, insulin is the only way to get the sugar from the blood into your tissues and your muscles and everywhere else where you need it. So that's what type 1 is. And then we'll talk about, let's talk, since we're in the autoimmune section, let's do 1.5. So 1.5 diabetes is essentially someone that we thought had type 2 all along, and they probably did for most of the time, but then all of a sudden they aren't making insulin anymore. Essentially, their immune system now also is destroying the cells that make insulin in their body, and now they're going to need to inject insulin. So it's kind of like type 2 that essentially becomes like type 1, essentially, because it just, at some point their own immune system started attacking it, and we can do tests for that. There's like fasting C-peptide. There's a couple of antibody tests we can draw to see if you have these antibodies to basically your own insulin producing cells, and that's what 1.5 is. And so you don't have to remember too much about that kind of stuff, because that's very small percentage. Like we're talking about less than 3% of all diabetes is type 1 or type 1.5. 97% is going to be, we can talk about right now, is the type 2 diabetes. Type 2 diabetes, we used to call that adult onset, but that's not really accurate anymore, because there's kids that are 8, 10, 12 years old that are developing type 2 diabetes because of the standard American diet, the poor lifestyle, everything, childhood obesity, all of those things. And so we don't really call it that anymore either. We just call it type 2 diabetes. And what type 2 diabetes is, basically your body becomes resistant to your own insulin. So you're making plenty of insulin. Usually you're making even more insulin, tons and tons of insulin, because your body's trying to overcome the insulin resistance. And I'm going to talk to you more detail about what insulin resistance is. And I'm going to kind of do a little demonstration in the room to kind of describe to you what insulin resistance is. And so before we get to that, though, I want to kind of go into, then there's also gestational diabetes, which diabetes with pregnancy. And we know that because of hormone changes and being pregnant, you're a higher risk. If you have any insulin resistance at all, it gets amplified, so the insulin resistance gets worse. And then a lot of times women will have to be on insulin and be on diabetes medications, essentially. And then most of the time, once they deliver the child, the gestational diabetes goes away. But we do know that women that have had gestational diabetes during pregnancy, are at higher risk later in life to develop type 2 diabetes. So it's definitely a risk factor, because we do know it's insulin resistance is the cause, but just the insulin resistance gets worse during pregnancy because of the hormone changes that occur in the body during pregnancy. So there's that. And then we actually it's not really technically diabetes, but we also talk about type 3 diabetes. And what type 3 diabetes is essentially Alzheimer's disease, so of the brain, dementia. We've started referring to Alzheimer's as type 3 diabetes. It's insulin resistance in the brain, because we know that that's a big contributing factor to dementia, especially Alzheimer's is insulin resistance. So it's lots of different components that contribute to different types of dementia and Alzheimer's, but that's one of the pieces that contributes to dementia, is insulin resistance in the brain. So this insulin resistance stuff is bad news. And this is what we really want to be treating. And most of the drugs that we take, whether it's insulin or all these diabetes medicines that are out there, they don't really treat insulin resistance. They're just lowering blood sugar. The only thing they have to be able to do to get on the market is to be safe and show that they can lower blood sugars, not actually reverse insulin resistance, things like that. So those are the types of diabetes. Any questions about those before I start diving into insulin resistance, what insulin resistance is? Okay. And so I have a big list, and if you go to the previous lecture, you want to see the slides that I had, there's a giant list of all the different chronic medical conditions that insulin resistance influences. And so again, let me go through like the definitions if you're interested in like the blood sugar levels that constitute prediabetes versus diabetes, just so you kind of have a reference there. And so A1C, is everyone familiar with hemoglobin A1C, that blood test? So it's a blood test that checks what is your average blood sugar over the previous 3 months. And so what it is basically we have, oh yeah.
What slide do you want to be on?
Oh yeah, go ahead, advance another slide. There's just some quotes. Desmond Tutu can read that. Go ahead and go to the next slide. So if you can stop at the insulin resistance one, that's what it keeps doing, is scrolling through all the slides, but has a list of insulin resistance. But so blood sugar, so hemoglobin A1C, so our red blood cells, we turn those over about every 3 months in our body. So our bone marrow puts out new red blood cells every 3 months. And so a certain amount of our red blood cells get what are called glycolated. So what that is basically it's like rust, so it's like we talk about oxidants and antioxidants and free radicals and all these things. So our red blood cells, a certain percent of them get a sugar molecule attached to them. And so that's what's called glycolated hemoglobin. And so it's a percent. So if you go, okay, so normal is 5.6% or less of our hemoglobin molecules at any one time. Like if we drew everyone's blood in here and we did an A1C, it's going to be, everyone's going to be, if they're normal, is going to be 5.6% or less. And so what that means is 5.6% of your hemoglobin molecules in your body at this moment in time are going to have a sugar molecule attached to them. And that's considered normal. If it gets to 5.7% all the way up to 6.4%, we consider that pre-diabetes. And if you look at it, you can actually look it up online. What's the average blood sugar of an A1C of 6.2? You could just type in 6.2 Amazon or whatever, Google, and it'll say, oh, that's an average blood sugar of about 140 or something like that. So it just, the percent equates to a number. And so if you were to wear a 24-hour glucose monitor for 3 months, it would tell you, okay, that's your average blood sugar. Sometimes it's lower, sometimes it's higher, of course, after we eat and things like that. That's what your average blood sugar has been over the past 3 months. And that's what hemoglobin A1C tells us. And so 5.7 all the way up to 6.4, we consider that pre-diabetes. And then 6.5% and above is considered diabetes. And there's other numbers, random blood sugar greater than 200 is diabetes, a fasting blood sugar greater than 126 is diabetes. So there's other numbers that equate, but that can give you the diagnosis, but those are the A1Cs that we look at. So just to kind of give you that figure in your mind. And then the other thing to talk about is that's insulin resistance has been going on in your body for decades before you'll ever have a rise in your blood sugar, because your pancreas is kicking out lots and lots of extra insulin to keep your blood sugars normal. And so you, again, half the American population has insulin resistance, but only, what are we at, 38 million now have diabetes, something like that, 39 million. So it's a lot, but even more, over 100 million have prediabetes. And so the insulin resistance is pretty much, if anyone's eating the standard American diet, for the most part, it's 2/3 of us have insulin resistance, and insulin resistance is bad. It contributes to all those things up there. Coronary artery disease, cancer, all the types of diabetes, even type 1, which we'll get into, chronic kidney disease, Alzheimer's, type 3, fatty liver disease, high cholesterol, high blood pressure, obesity, polycystic ovarian syndrome, neuropathies, retinopathies, erectile dysfunction, and the list goes on and on. Insulin resistance contributes to all of those conditions. And if you think about that, insulin resistance, it's kind of like the silent killer, so to speak, because you might not have high blood sugars. You'll have insulin resistance for all these years, not even really know it, but you might have a lot of these things. And so that's why we see in medicine, when someone has, high blood pressure, high cholesterol, or heart disease, or any of those things, they tend to, we got to check their A1C because they might develop diabetes, because we know that all these conditions, they're related. It's not like they're all diseases in a silo. They're all related to each other. It's all chronic inflammation and glycolation and with the sugar and chronic inflammation and oxidative stress, all these things that contribute to it. And so it's really important that you understand what insulin resistance is, and that we can try to treat that. So go ahead and go to. Yeah, you don't have to do any of the videos. Yeah, on the back. Question.
Do you need to be diagnosed with insulin resistance?
So good question. So the question is to be diagnosed with insulin resistance. So the best test, and I have a slide for that later, but and we'll talk about that. You can leave it on the keto caveat. I can leave it there because I'm going to get to that, and I want to go over that slide. But so the best test for insulin resistance is a glucose tolerance test. So like the one women that have had babies you had when you were pregnant. So you get the 70 grams of glucose. So you start off doing a fasting blood sugar. What's your fasting blood sugar? And then you drink 70 grams of glucose. Then you check the blood sugar in an hour and 2 hours, and what your sugar is after that. That is actually, even though it's very antiquated, that's actually the best test for insulin resistance, is your glucose tolerance. And so I'll get into some of the details on that when I describe what insulin resistance is first. And so it's important to, and then a lot of other signs of insulin resistance besides the glucose tolerance test that you might not do well on is the central adiposity. So you see about the visceral fat, but even the fat you see around the middle, that is an indicator that you likely have insulin resistance, but it's not foolproof, because there are people that can look thin on the outside, even don't really have a big belly, but then they still have insulin resistance, and sometimes even already have type 2 diabetes because they have fat in places that they shouldn't have fat, like inside their muscles, inside their liver, inside their pancreas, so inside their organs essentially, so you don't see it. And so that's why we're really kind of going away from BMI for just somebody really healthy based on their body mass index, and then there's a little bit better by doing a waist measurement, is a little bit more accurate than BMI, but even then that's kind of not really holding up either, because there's people that have big bellies, but they don't have any insulin resistance. They actually do fine on their glucose tolerance test, and they never develop diabetes. And so then there's people that are thin that don't look visually heavy, and then they develop insulin resistance and diabetes and have all the complications. So we know there's more to it than that. Yeah.
I get to this later, but
Yeah.
one of the things that I take is losing weight. Is
Yeah.
maintaining weight while being type 2 diabetes, and trying to figure out what foods to eat that aren't going to
Make you
raise the
gain weight.
numbers and yet keep my body weight up.
Yeah. So you're trying to gain more weight?
At least
Maintain, because you're trying to maintain like muscle mass and things like that. Okay. Yeah. So because most people that have type 2 diabetes will actually gain weight from the medications. Insulin makes you gain weight. A lot of the other medications often will make you gain weight at the same, and so a lot of times, and then weight gain can actually contribute to insulin resistance too. So it can be counterproductive. Like, I used to put a lot of my patients on insulin those years ago, trying to get their blood sugars down. Yeah, I could get their blood sugars down, but then they gained weight, and that actually was making their insulin resistance worse, because unless I was treating the diet and lifestyle, which I didn't know about then, like I do now, I wasn't doing anything to reverse their insulin resistance. I was just trying to overcome their insulin resistance, drive their blood sugars down with more medications and more insulin to kind of overpower that insulin resistance that's happening. So I want to describe insulin resistance so you kind of have an understanding of what it is. Okay. So some people actually have talked about genetically, or kind of, because there is genetic predisposition to developing insulin resistance. So for example, the Tarahumara Indians and the Copper Canyon in Northwest Mexico. So they have no diabetes, no heart disease, none of that. And they're eating, 90% plant-based. They're eating, we've actually studied these people. They're the running people, Born to Run, that book, if you've ever read the book Born to Run. So they run these 48 hours straight, this kickball game, and they do all this. And they're not vegan. They occasionally would kill a pig for a celebration and things like that. But they are eating beans, rice, tubers, fruits. So they're eating mainly plant-based diets. So they have no heart disease, no diabetes, none of that. And we know that population completely different than here. But then genetically, they're the genetic equivalents of the Pima Indians in Arizona. So the Pima Indians in Arizona are the genetic relatives of the Tarahumara in Mexico. And the Pimas actually have some of the highest rates of heart disease, diabetes. So they're genetic equivalents identical to them, but they're riddled with diabetes and heart disease because they're eating government cheese and spam and just all the standard American, even worse than the standard American diet, kind of the food insecure and just horrible. And so the reason I'm telling you that is that there is a genetic predisposition, but that can be overcome by your diet and lifestyle. It's not your fate, basically. So I wanted to kind of give you that little bit. And so the reason we think it might be, so we know it's genetic to be predisposed to insulin resistance, but some people actually think that it's a protective mechanism. And so I'll tell you kind of what that means. And so think about, like, did you ever watch like like My 600-Pound Life and some of those shows where some of the people that are 600 pounds really, really large, it's amazing. A lot of times they don't have diabetes. And you're like, well, how come they're so heavy? Well, it's because they don't develop insulin resistance. And so they store their body fat in their subcutaneous tissue. They store it where the body's kind of meant to store it. It's kind of like Dr. McDougall used to say, that fat we eat is the fat we wear. It's the metabolic dollar for when we have famine. So your body always wants to store fat. It wants to, because it thinks, well, you might not eat again for a week or 2 weeks or a month, right? And so the people those of us that have survived to today are ones that have been good at storing fat. And so because of the possible famine that might happen. And so if you think about, though, to a point, it doesn't give you a survival benefit, because what if so maybe 40, 50, 60 extra pounds of fat might be beneficial if you're going to not eat for a month. That would actually be more likely to survive, right? But then if you're 100, 200, 300 pounds overweight, you're not going to be able to run from the tiger. You're not going to be able to climb the tree. You're not going to be able to move around and search for more food and shelter. It wouldn't be beneficial to do that. And so we think that the body developed insulin resistance because now you're not storing the fat in the subcutaneous tissue anymore. You're starting to store it in your liver, in your muscles, in your pancreas, and in those organs, right? Because it's not going to limit your ability to kind of climb and get away and things like that. Because it's again, like the people that are thin, oftentimes, especially in Asian countries right now, we're doing a lot of studies on them because they were developing diabetes before they were even overweight at all. Like they actually look normal and they have diabetes. Whereas in America, it was mostly 20, 40, 50, 60 pounds overweight was when we started to see people here developing diabetes over the last 50, 60 years or so. And so there's thought that maybe insulin resistance is a little bit of a defense mechanism. And so, so that being said, let's talk about what insulin resistance is. How does the body put fat in the muscles? How does it put it in the liver? And how does it put it in the pancreas? What's happening there? And so we know that, so let's just pretend that this sanctuary is the inside of a muscle cell. Okay, so we're inside a muscle cell, and back in 2018 to 2020, I had little cards and I'd make people stand up, and somebody could be a fatty acid, somebody could be a mitochondria, someone could be a glucose molecule and things like that. But it, kind of got a little jumbled, but you guys can play this visual game with me. So let's say, okay, we're inside here. This is the inside of a muscle cell. Let's say this piano here is the mitochondria. So did you guys take biology in high school or anything with what the mitochondria is? It's the powerhouse of the cell, right? It's where basically ATP is produced. So the energy for the cell gets produced here in the mitochondria. And so the mitochondria is the furnace. Think of it like the furnace. It makes the decisions. It decides what fuel it's going to burn. and it's going to decide what comes in and out of the cell. It's kind of it's in charge. Okay. Now let's pretend that the fellowship hall out there is the bloodstream. So those two doors in the back, let's pretend those are closed. And so the blood's flowing out there in the fellowship hall where the lending library is out there and everything. And so inside the cell here, we have some fat droplets. So fat droplets can, in our diet, when we eat, whether it's an avocado or a cheeseburger or something like that, there's going to be some fatty acid, fat droplets that come in here. Because the fatty droplets, they don't really need an invitation to come in. They can just kind of come on in. And so there's some of them in here. And then we have from our last meal, we have some sugar molecules in here too. And so the mitochondria over here, it can burn two fuels. And if you guys were here during the calorie density lecture, Jeff Novick talked about that, right? Fat and glucose, right? As the two preferred fuels that the mitochondria wants to burn here to make energy. So the mitochondria says, okay, I got some fat droplets here. I'm burning up. I'm making energy from those. Yeah, from my meal a few hours ago, there's still a few sugar molecules in here. I'm burning up those, and gosh, there's not very much in here right now. So I wish I could get some more either fat or sugar in here. I need some more. This is normal physiology, okay? And so what happens is you eat a little food, no matter what it is, and your sugar goes up, all right? And so in response to that, your pancreas secretes insulin. And so what insulin does is insulin knocks on that door. So insulin is out there in the bloodstream, and the blood sugar is starting to go up inside the bloodstream out there. Blood sugar is going up. Insulin comes on behalf of that blood sugar and knocks on the door and says, hey, mitochondria, hey, we got some extra sugar out here in the bloodstream. Can we come in? We want to come in. And the mitochondria says, yeah, you can come in. We got not very much fat in here. We don't have very much sugar in here anymore. Yeah, come on in. Insulin opens the door, unlocks that door, the sugar comes in, and the mitochondria burns it up. That's what normal physiology is. That's what's supposed to happen. Now what happens in insulin resistance is this. So now let's just say we eat bacon double cheeseburger, donuts, standard American fare, a lot of processed food, a lot of excess calories. The sugar's going up, a little bit higher than it was on the normal physiology, but not significantly more. And so what happens then is, remember that fat doesn't need an invitation, it just comes on in here. And so tons and tons of fat starts building up inside this muscle cell inside here. And so now there's just tons of fat globules in here. And having that specially saturated fat, which is the fat from mostly animals, so cheese and bacon and chicken and sausage and all the saturated animal fats are the biggest culprits. They actually block signaling and cause ceramide production and all kinds of toxic metabolites inside here. But then there's tons and tons of fat in here. And so now, when the blood sugar is going up out there, the insulin comes and knocks on the door. Hey, sugar's getting a little bit high up in here in the bloodstream. Can we come in? Mitochondria says, no way. You're not coming in. I got so much fat in here. I got to burn up first. I'm not letting any sugar in here. I got to burn this fat up first before I'll let the sugar come in. That's what insulin resistance is. So the insulin's out there. There's lots of insulin pounding on the door. The sugar's going up and up in there, out there, and it's not able to get in. Now you can inject insulin and overpower that somewhat. So kind of think of it as, like my patients that I would just add more and more insulin to them. They gain weight because it does cause is to store more body fat, insulin does. And so then you can kind of knock that door down a little bit, so to speak, and get some of that sugar in. It does work, but it doesn't want to. And so then you start coming to these classes or whatever, and you start eating a whole food plant-based diet. And as long as you're not eating too many avocados, too many nuts and seeds, which are also high in fat, and you can actually, this fat that's in here will start to get burned up. And so you get down to where you're getting that fat outside of the cell. So this is the fat inside this muscle cell. It has a name. It's called intramyocellular lipid. Intra means within, myo muscle, cellular cell, lipid, fat. So fat inside the muscle cell. We actually have technology, we can see it now. And so I was telling you about the Asian population where they're thin, but they're developing type 2 diabetes. We did something called magnetic resonance spectroscopy. So you can do MR spectra scans of people, and it's in clinical trials. They're doing it right now as we speak, trials on this, where you can see where the fat is. And so someone with insulin resistance, you're wondering how do you test for insulin resistance? The glucose tolerance test, which, how that works, you can kind of probably visualize that after that little demonstration, how that works, right? Is that then now you get all that fat gets out of there. And so when you do the spectra scan, you see where the fat is. So you see the fat in the liver, you see the fat in the muscle cells, you see the fat in the pancreas. And then what ends up happening too is the excess fat is very toxic. And so you get fatty liver, and you can get cirrhosis of the liver because of the fatty liver. Your pancreas the cells that make insulin start to get injured because of all the insulin resistance and fat accumulating in the pancreas. And so then what happens with a lot of times when you finally have insulin resistance for decades, and then suddenly your sugars skyrocket and you get diagnosed with diabetes, is what's happening is now your insulin producing cells are kind of fried. They're kind of tired out. So they've been working so hard for so many years trying to overcome that insulin resistance to keep your sugars normal. And then all of a sudden they just kind of, you can't do it anymore. And they don't produce as much insulin as they were before. And so now the sugar's really stuck out in the blood cell and in the bloodstream, and it can't get in here. And so any questions about the visual of what insulin resistance is? So it's not caused by sugar. Insulin resistance and diabetes is not caused by sugar, it's caused by fat. Fat in places that's not designed to store fat. We're not designed to store fat in our muscles, in our liver, in our pancreas. Although there is some debate about that. Maybe that was this defense mechanism, putting it there instead of so much in our subcutaneous tissue, because it's not, it could be harmful too. But I think, we're so far beyond what we did hunter-gatherer days that it doesn't really apply anymore. It just kind of a interesting thought experiment there on that. But and there's still a lot of debate about that. But insulin resistance is what we really want to get rid of. And so things like eating a plant-based diet, getting good sleep at night, exercise. So what's really interesting about exercise is that exercising muscles don't need very much insulin, if at all, to get sugar inside. So that demonstration where knock, 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 we need to let some sugar in. If you're exercising muscles, and it can last for 12 to 24 hours after your last workout, actually pulls more sugar from your bloodstream into your muscles because of the exercising muscle. It's really important. And then, lowering stress because of all the high cortisol levels that you get when you're in a lot of stress and not sleeping and things like that. Cortisol is like the natural steroid, which makes you hold on to fat, which actually worsens insulin resistance. So all the, like when you guys were here with Pam Burrell, and stress management, social connection, good sleep, all those things are going to contribute to lowering that insulin resistance, lowering those stress hormones. And then eating a plant-based diet is the solution to actually getting rid of insulin resistance. And so what I wanted to say now is, like, before I get to the keto caveat thing, and then answer any questions, give you guys a break with my rambling here, is that it's really, when you have someone with type 2 diabetes, what will happen a lot of times is their sugars will be, in the beginning, will be really high when they switch their diet sometimes. I mean, sometimes they'll go on a plant-based diet, they get rid of that fat out of the muscle cells really quickly, and their sugars normalize really quickly. I've had it happen within 2 or 3 weeks on some patients, and I've had it take like months in some patients, because just depends on how they respond, how much insulin resistance they have. So I've had patients where, maybe they're not completely doing plant-based, but they're transitioning. They're eating more fruits and vegetables, more beans, more whole grains, but they're still eating some cheese and some meat and some processed foods and things. And so it's still contributing to their insulin resistance a little bit. And so then when they eat something like beans and rice or fruit, their sugar goes really high. And then they say, oh, bad fruit, bad beans and rice. My sugar went high when I ate that. Well, it's not the beans and the rice and the fruit's fault. It's the insulin resistance fault. It's the fault of the fat that's still inside this muscle cell. Whether that was fat from cheese or chicken or pork or whatever it was, even if they haven't really been eating very much of it in the last few weeks, it's still going to sometimes take a while to get the fat out of here. out of inside of this muscle cell so that the insulin can do its job and let the sugar in. And so it's almost like doing your own glucose tolerance test. And so you can actually, when I'll know that someone's really doing well reversing their insulin resistance is, before, when they ate the beans, the rice, the fruit, their sugar went up really high and they had to use extra insulin or whatever to cover that. But then 6 months later, because they've been doing well, getting rid of all the red light foods, all the meat, the cheese, the eggs, the dairy, the oils, the processed junk, as they get rid of that 6 months down the line, now they eat the beans, the rice, and the fruit, and their sugar doesn't go too high anymore. Oh yeah, it doesn't spike at all anymore. But like I went and had a cheeseburger, and then my sugar the next morning, so I had a cheeseburger for dinner, and then when I ate my oatmeal the next morning, my sugar went really high again. Insulin resistance can come back. It can really respond and come back that quickly. Usually it can go away quickly when you've kind of been working really hard on reversing it over time. It can still really, people that have continuous glucose monitors can understand this. But oh yeah, I really responded when I ate that really fatty meal. And the next high carbohydrate meal was really spiked my sugar. But when I didn't eat the bad food, the fatty food, then it didn't spike it too high. And so you can see that in real time. And we know we can actually, we knew this way back in 1928, we could actually incite insulin resistance even in the short term. So what they did, this is the Sweeney study back in 1928, they took medical students, two different groups of medical students that were 18 to 22-year-olds, whatever, normal, no diabetes, just normal kids. And they put one group on a really high fat, animal fat diet. And the other group, they put them on, it was not even a really healthy diet. It was lots of sugary foods. It was fruit and sugary foods, and was just like some processed foods, but just really high in sugar, not super healthy necessarily. But just what they were trying to show is really low fat, but high in carbohydrate, or really high in fat and almost no carbohydrate. They could incite insulin resistance by failing a glucose tolerance test in the kids that ate the high fat. The insulin couldn't work.
I think it's going.
Influences of all those foods there. So I'll take a break here. Any questions about anything so far?
Well, one of the things that has puzzled me is, with eating the carbohydrates and fruits and what have you, which is what I think normally we think impacts diabetes. But what you're saying, that doesn't do it, it's the fat.
Correct. It's the fats, not the sugar. And we knew this way back in 1928, but it just hasn't, even still today, it's still what we call the carbohydrate centric model of diabetes, which is just basically, let's just control blood. Same thing I was doing back in 2008 is like, oh, let's just control blood sugars. Let's do low carb. Let's keep the carbohydrates low to keep the blood sugars low. And so then the numbers will look good, but you can actually still be worsening your insulin resistance. And if you guys can scroll to the keto caveat slide, I can kind of go over that because that's a good segue into that.
But then you'd also have to be careful about the type of carbohydrate. I mean, if you're gonna eat ice cream, that's one thing, but if you're gonna eat fruits and grains,
Yeah.
what have you, those carbohydrates are not gonna.
Right. So two things there, good carbohydrates and bad carbohydrates. But one thing I want to mention, because you brought it up, I'm glad.
Both.
What ice cream, for example, where do you think most of the calories come from in ice cream? Is it fat, carbohydrate, or protein? Fat. Yeah, it's actually fat. There's a lot of sugar in ice cream. Don't get me wrong. It's a horrible food. It's just processed. It's just sugar. It's fat. It's lots of salt. But if you ever tasted melted ice cream, it's like, oh my God, it's so sweet. I mean, it's just like, you almost can't even eat it. But when it's frozen, it makes it more mellow. But still, even though it's loaded with sugar, most of the calories in ice cream is fat. So when people will say, well, I have diabetes, I gotta cut carbs. It's like, well, two things there. A lot of people don't understand where most of their calories are coming from, even with junk foods. Things that they thought of as being carbohydrates, really, or most of their calories are still coming from fat. And so that's one issue. That the other is there are, good carbohydrates and bad carbohydrates. And so that Jeff Novick video, he has a whole section on carbohydrates on there, on the video section where I showed the calorie density stuff. He has a really good section also on carbohydrates. And so to know whether it's a good carb or a bad carb is basically the package, right? And so in these classes, we always try to teach you guys to never label a food as a carb, a fat, or a protein, because that's doesn't really tell you what something is. Remember the slide where Jeff Novick showed the Fig Newman's cookies? So there's like, here's 3 Fig Newman's cookies, 200 calories, and here's 200 calories with a cantaloupe. And it was like a whole cantaloupe, basically. And so they have both of those foods have the exact same percentage of fat, carbohydrate, and protein, but completely different packages, right? So they have essentially the same amount of sugar, but one is loaded with water, fiber, vitamins, minerals, nutrients, perfect for you. And the other is just sugar by weight, basically, and just junk, right? And so that's a great question to bring up, because you want to, like Charlie always talks about, that there's mixed messaging. It's like, we all know fruits and vegetables are healthy, but where are most of the calories coming from with fruits and vegetables? Carbohydrate, right? But then they say, but you have diabetes, you should cut your carbs. It's like, well, but not fruits and vegetables, right? And even experts in diabetes would say you still eat lots of fruits and vegetables. They might say, do the lower glycemic index fruits, more berries because they're higher in fiber. Maybe don't eat quite as much watermelon and some of the other melons because they're a little bit higher on the glycemic index and things like that. And so what we want to get you guys talking about in these classes is, what are the food packages I'm choosing to get my carbohydrates, fat, and proteins? That's ultimately where we get all our calories, is from those 3 macronutrients. And so we want it to be unprocessed whole plant foods for the vast majority of everything you eat, because you want the fiber, you want all the antioxidants, vitamins, minerals, fiber, everything that comes in these unprocessed whole plant foods. So yeah, let's talk about the keto caveat here, because you'll hear people in the low carb keto realm say, hey, my fasting insulin levels went. So when I went from the standard American diet to a keto low carb diet, you'll hear them say, oh yeah, my fasting insulin levels went down, my blood sugars, my A1C went down, my insulin requirements went down, my blood pressure went down. All the numbers all look better, but it actually hides insulin resistance. And I'll explain to you how that is. And remember how insulin resistance is the real culprit here, not just the blood sugar, right? And so, because if you keep your carbohydrates low enough, your blood sugar out in that bloodstream will be stable. It can stay pretty low, but you can still be riddled with insulin resistance. You can still have tons of fat inside this muscle cell, because if you're eating, butter in your coffee and bacon and sausage and cheese and things like that, because you're low carb, then even low carb, they try to limit cheese a bit because it is high in lactose, which is sugar. And so, but because of that, your numbers could look better, but you're still riddled with insulin resistance. And one of the reasons we know this is because you can put somebody that's on a keto or low carb diet, give them a glucose tolerance test like we talked about, and they'll fail it miserably because there's tons of insulin resistance. They still have tons of fat inside this muscle cell. So it's kind of, Dr. Greger actually has an analogy, one of his books about this process, is like, okay, so if you fell and broke your hip, your choices are to stay in a wheelchair the rest of your life and it's not going to hurt, right? Your hip's broken, but you're never going to walk again. You're just going to stay in the wheelchair and just live the rest of your life in the wheelchair. You don't need to have the hip replaced. You can just stay in the wheelchair, right? And after a while, it's not going to hurt you anymore, and it's just going to be that way. That's what being on a low carb keto diet's like. You're just never going to eat carbohydrates anymore. You're just gonna eat all these high fat foods that actually studies show increase your risk for heart disease and all these bad chronic diseases, because you still have insulin resistance, or you can have a surgery and fix the hip and you can walk again. And so fixing the hip is basically, let's eat the right kind of carbohydrates. Let's go on a more whole food plant-based diet. Even if it's not 100%, let's go on a more whole food plant-based diet and actually walk again and get our hip fixed, right? And so you can stay in the wheelchair and let it careen down the down the downhill slope, or you can get it fixed, so to speak. Let's fix the insulin resistance, right? Let's not ignore the insulin resistance. Let's fix it. And the only way to fix it is to get that fat out of those muscle cells, out of the liver, because actually that's one of the some of the studies that have been shown not only to being on a low carb diet to worsen your risk for heart attack and stroke, actually by over 50%. A Swedish study that was published, and then also the blood perfusion studies in the heart actually show after a year you have 50% more clogging of the arteries on a low carb, animal-based low carb diet, whereas the arteries, the blood flow through the heart got better by 30% in the plant-based diet. So we have the studies that show that that's not such a good idea. But what I do always say about people that come to me, I have patients come to me all the time that are doing low carb keto, and I never throw them under the bus. I just say, hey, this is great. I'm happy when we have somebody that comes to me that is doing low carb or keto, because it's like, well, a couple things. They care about diet change. They're ready for change. They're into it. They're somebody that's motivated. So I love that. And then two, what I love is that generally when they come to me, they've cut out processed foods. So
Yeah.
wow, that's a huge hurdle. It's like, so that's great. And then most of the people that come to me, they are eating more vegetables than they were before. So that's great too. But then I give them the studies and I tell them about the insulin resistance stuff. And I say, hey, but it would probably be better if we maybe start substituting, maybe what are the meats that you love the most? And, if they can get them to maybe do elk or venison, or, chicken instead of bacon and sausage, there's worse, there's animal foods that are not as harmful. They're all harmful, but there's animal foods that are less harmful than other ones. And so it's making transitions. And so I work with them. I say, hey, let's get you on more beans. Let's substitute in more servings of beans instead of as much meat. And then if they're doing the butter in the coffee, let's not do that. And things like that. So you can kind of work with them one step at a time, give them the science of what, it's maybe not the best thing to do long term. Maybe it's okay for 6 months or a year, but I did my master's thesis on low carb diet, so I know all about them, and I did it myself for 3 years and about 15 years ago. And so I know what it's about. I've done it. It's just, you have to kind of adapt to the science and change, just because I believed in it at one time doesn't mean it's right for the long term. And then we could get into discussions about what's better for the environment and all those other things that we could talk about. Yeah, do you have another question?
Oh, it's not really a question, it's a
Oh,
statement.
yeah.
I think you are 100% correct about it being a segue.
Yeah,
A lot of people that start that they're so like hopeless feeling that they start somewhere.
Mhm.
And had I known your background started that would have been great.
yeah,
Because they push a lot of meat. They push a
Yeah.
lot of meat, and
right.
I had no idea until I came to this class that I didn't need meat. I was having panic attacks if they want me to eat no meat. They're nuts. Now, I think since in the month that I've been here, I think I've had this big of a piece of chicken.
Yeah,
That's it. And nowhere in my life did I ever think that I could do that at all. So
Oh, good
thank
deal.
you for teaching us, but
yeah,
definitely it's a segue that people are trying anything.
right. And a lot of people have loved ones that maybe they're not ready to give up animal products. But then even if they aren't going to do it for their health, then you can tap into other things that they might care about, all the environmental pollutants and eating high on the food chain, high risk for cancer, high risk for, diabetes, heart disease, all these things that are associated with more animal products. And then, sustainability and, feeding the planet, like the Eat Lancet Commission that came out, was that in 2018 or so, it said, 95% of the world's population for sustainability, both environmental and to feed 10 billion people by 2050, we need to be eating a more plant-based diet, at least 95%. I mean, there are places on the planet that can't be 100% plant-based because just resources that they have, coastal communities, third world countries, they might need to eat fish just to get enough calories. So there's, you have to be responsible. There are places and pockets on the planet that, can't be maybe 100% plant-based. And so that's what the Eat Lancet Commission came in. It was over 38 scientists from 16 different countries came together and said, hey, what can we agree on? They had environmental scientists and they had food sustainability, and they had, doctors and nutritionists, dietitians, all these specialties come together and come up with a consensus for the world diet. So it's called the Eat Lancet Commission. And really interesting in it, and that's essentially what it is 95% whole food plant-based is what we should be doing. And actually said that if you could be 100% plant-based, that's even better for your health, even better for the environment. But again, taking into consideration there are places on the planet that maybe can't quite do that. And so it takes into all the different things into context. So my point is, hey, just because we can eat animal products and junk food doesn't mean we should. Whether even if we don't care about our own health, but we care about our grandchildren, our great grandchildren, future generations, sustainability, environmental reasons, it's actually better to eat more plant-based for so many other reasons, just besides health. So, and diabetes, for example. Yeah.
What category?
Yeah, saturated fat.
Repeat the question.
Yeah.
Saturated fat.
Yeah, so saturated fat is, so think of it this way. So it's fat that is solid at room temperature. So if you take like butter, yeah, so it's like bacon. So this is actually, I steal this from Neil Barnard. So Neil Barnard grew up in North Dakota, Fargo, North Dakota. And so he said his mom would fry up the bacon, and all the bacon grease was in the pan. She didn't throw it away. She put it in a jar, and she could put that jar and put it on the shelf, right? And so then the next time they cooked eggs the next morning, she could take a spoonful of bacon grease, put it on the frying pan, and fry the eggs, right? And so what did that bacon fat? It was liquid when it was hot. It was liquid, right? So what does that bacon grease look like the next day? White. It's solid, right? And so that's saturated. Saturated fat is solid at room temperature. Whereas if you take olive oil does have some saturated fat, but it's mostly monounsaturated fat. So it is the healthier fat, even though you talk about in these classes that oil is a processed food, it's not a healthy food, but olive oil is healthier than bacon grease, right? And so that olive oil, extra virgin olive oil, that is as liquid at room temperature. So that is unsaturated fat. So it has to do with the organic chemistry. It has to do with the bonds, how many hydrogen bonds it has. And so all you have to remember is solid at room temperature. And then trans fat's even worse. Trans fat is hydrogenated oil. And they've now gotten rid of that from the food supply, because trans fat was even worse than saturated fat. Trans fat was even more unstable. It actually destroyed cell walls and let basically fat particles, cholesterol penetrate your arteries, even worse than saturated fat. So it's even worse. Trans fat, well, now they're out of the food supply, so they're hydrogenated fats. So they're synthetic. There are natural trans fats in only in animal products. Like, so if you eat a cow, beef, there's a little bit of trans fat in there because that's naturally occurring fat in animals, small amount, but essentially it's the Crisco. Remember the old Crisco oil that we used to cook with? Fried our, melted it down and ate potatoes and donuts and stuff. We used to do, my dad used to have a little fry daddy thing, and we'd make donuts like Halloween. It was kind of a thing. And that was Crisco, that was solid trans fat. And that's even though it's, yeah, that's the best way to think of it, is artificial fat. But you don't really have to worry, unless you're eating animals, you don't really have to worry about trans fat anymore, because it's now been outlawed in the food supply. Because it's so bad, it was removed from the food supply in like 2017. So, but yeah, saturated fat, solid room temperature, mostly. So the number one source of saturated fat in the American diet is cheese. Number 2 is pizza, which is more cheese. Number 3 is ice cream. So we were talking about ice cream. 4 is, I think, pastries. Basically all our sweets and pastries and things like that, processed foods. I think 5 or 6 is chicken. And even though chicken has less saturated fat than bacon, Americans eat so much chicken that it's like the number 5 or number 6 source of saturated fat in the American diet. And then all your pork, fish. I mean, even fish has saturated fat, even though it has healthy fat, it also has saturated fat too. So you just in general you want to avoid, because you're going to get fat if you're eating 100% plant-based diet, no animal products whatsoever, no processed foods whatsoever. Like Dr. Esselstyn, like Charlie, you're eating nothing but unprocessed whole plant foods. You're still getting 10 to 15% of your calories every day are still coming from fat. because broccoli has fat, potatoes have fat, everything has fat in it. So there's no such thing, nuts, yeah, if you're eating peanut butter, nuts and seeds, they're really pretty high in fat too. So there's no such thing as a no fat diet. You're still gonna be getting 10 to 15% of your calories from fat, probably still getting 20-ish% of your calories from protein, even on whole plant foods. And then the rest is like carbohydrate. So again, not to focus on those macronutrients because that can be misleading, as I talked about earlier, but just, yeah. You have some comments?
So let's try to get a little practical for the end of this. Thank you, Scott. We want to make sure, what is the main message takeaway tonight?
Don't eat ice cream. No, I'm teasing.
Okay.
I'm teasing.
Yes.
Don't eat pizza.
That's okay too.
What is it?
Don't eat pizza.
Eat plants.
Eat plants. Yes.
Eat plants. What kind of plants?
Crucifix,
Huh?
green leafy crucifix,
Okay.
green leafy.
What is the key problem with diabetes? The
Yeah.
main takeaway message. I hear it from one, I hear it from two.
Fat.
Does everybody get that concept?
Yes.
It's the fat. What did you think it was before tonight?
Sugar.
Carbohydrates.
Well, carbohydrate.
Carbohydrate.
Yes.
That message of carbohydrate being the cause of diabetes has been promoted since all time.
So why did
And
we do that?
so why do we do that? What we have to ask ourselves is to look around and see all the education that we've received from the older registered dietitians, doctors, and medical profession. Where has that taken us? What's the problem? How many of us have diabetes now? Over half of our population
Really?
is pre-diabetes or diabetes. Because of the advice that is flowing through our culture. The advice is avoid carbohydrate. You have 3 foods, macronutrients that come from any of the food choices that you eat. What are they? Fat, carb, protein. If you tell someone stop eating carbohydrate, what do they eat? Fat and protein. What are you doing to their diabetes when you make them eat more fat? Are you making it worse?
Creating a slower.
That has been the message that is throughout our culture. So how do we stop that? Go ahead.
So is that why, in the previous class, you said you're only supposed to have a quarter of a cup of nuts?
That's one of the reasons, yes. Because nuts are really high calorie fat food. And so even if it's not saturated fat, if you eat enough fats in your diet, you are still going to load your cells up with excess fat, which is going to lead to insulin resistance. And if you looked at the chart that Scott had of all the problems associated with insulin resistance, it's not just diabetes. So one take-home message:
Eat that.
stop eating so much fat. So that brings us to the next practical matter. Where are you getting your fats? If you think about it, because you've been focusing your attention on carbs. I don't want to eat too much potatoes, and I don't want to eat too much pasta, and I don't want to eat, right? If you have problems with diabetes, what should your thoughts be now? And what foods are problematic?
I got the meat.
What?
Meat,
Meat. Meat has how much fat?
a lot.
About 35% fat for steaks. Chicken, how much fat? 24% fat. That's if you take the skin off and you just eat the white meat on the breast. It doesn't look like there's any fat there, but there is fat. A lot of it, 24%. Plants have less than 10% fat. Most all plants have less than 10% fat, except for nuts and.
That's why
Steve.
things that don't have a lot of fat in them.
Yeah,
No fiber.
eggs are an animal product. They have no fiber. They have a lot of cholesterol, which is fat. Cholesterol is fat. That's the message that we need to help people understand. Where are you getting your fats? So if you understand that eggs are not a healthy choice if you have diabetes, it will be in contradiction to what you see on the internet and the hype that eggs are healthy for you and whatever. Because you'll see that. Huh?
Sponsored by the egg board.
It's sponsored by the egg board. What other foods are high in fat in your life that you may say, maybe I should kind of avoid those if I want to control my diabetes? What else? What is it?
Pastry.
Pastry. Yeah, so pastry, the fat is put in the pastry. It has sugar also. That is a double trouble, right? Bad carbs and a lot of fat. What is another fat that we all love because it breaks down into a chemical that lights up our brain? What is it? Cheese and dairy. How many of you just love cheese? I know I did at one time. I think of it now as poison. Why do I think of it as poison? Because it has so much fat. It's like about 70% fat. And oils, that olive oil that you think is so healthy because it's part of the Mediterranean diet. How much fat do you think is in that? 100%. It is not going to help your diabetes by slopping it on your salad or by cooking with it or by frying anything in it. Oils are not going to help your diabetes. So I just wanted to make sure you understood the main message. It's not the carbohydrates. It's the fat. Now, carbohydrates in their refined form are definitely not healthy for you. We're not trying to tell you that you can eat all the carbohydrates you want in the form of white sugar and white bread and white rice and all that stuff, right? We're not telling you that. We're just telling you the thing that you've been missing, the key to improve your diabetes, it's the fats that you've been avoiding or not realizing are really what are the cause of your diabetes. And if you eliminate those fats, you will find you eliminate those drugs, just like the people in that I got the cards and the emails from. You could be one of those people. That's what we want for you. We don't want you to not like what you're eating. And I want to tell you, I love what I'm eating. And the meat, dairy, and cheese, eggs, they're off the menu. There are so many wonderfully tasty plant foods. And if you listen to Tamara at some of her cooking demonstrations, you will learn about that. And so I encourage you to kind of follow her around this area until you learn the skills that you get really comfortable and you love eating some different things. It's sort of like traveling to a new place. Like, if you haven't been to the Galapagos Islands or you haven't been to some place, Madagascar or African safari, and you go there and it's just like, wow, this is great. It's new. It's interesting. Same thing can happen with changing foods. Even though you say, I don't think I can give up. Try not to do the, I don't think I can give up. Try to get rid of that. And try to think, I wonder if I could really improve my health and really enjoy what I'm doing when I do it.
Right.
Try to be as positive as you can about it, because otherwise it's a drag and a drain. Any questions? Yes.
For me, I just started doing it right away, and I've been vegan for about as long as the last thing.
How long has that been?
What's the question?
Repeat the question.
So she was just saying that, she's been vegan for 6 weeks and she feels great and it hasn't been hard. Do you miss anything? She misses the oil on the salad. You'll get over it, I promise you. Balsamic vinegar tastes really good on salad. Yes.
Something that I did it for that exact reason is I started putting the capsule of the vinegar, cause he says to get vinegar on it. And then I put the nutritional yeast on my salad.
Nutritional yeast is great. It gives you a little cheese-like
Yep.
flavor.
That's delicious.
But the oils, I know that's a hard one. Why is it so hard? You like it. It lights up your brain. But it doesn't help your diabetes and it really doesn't help other issues in your body. If you like oil, eat the olive, eat a bit of avocado, eat a little nuts, but not too much because too much oil is not. Anything else? Yes.
Two things. One, olives versus olive oil. It takes 40 olives to make 1 tablespoon of olive oil. You can eat some olives, and not too many people would sit down and eat 40 olives. And there's the ratio of that. That's one.
That's an excellent point.
Number two is some of this information, and depending on audience, a little bit of doom and gloom, but to throw a ray of hope out there. Dr. Greger, in some of his presentations and writing cites, it was a small study, but to use whole food plant-based diet to treat long-term insulin patients, diabetics, and one person in that study was literally 20 years on insulin and off insulin in 16 days. There is light at the end of the tunnel.
And that's a good point you bring up. If you go to his site, nutritionfacts.org, is his website, you can do a search on diabetes and you will find that video, how to not die from diabetes, something like that. How to reverse diabetes. They're right there. They're excellent videos. And we encourage you to go to that site. And if you can't find it, send us an email. We'll help you get there. Any other questions?
Well, I have a history question. This is bringing up, when I was in high school and my dad was driving me to take my SAT class, he gave me a Butterfinger. Was that trying to light up my brain?
A Butterfinger. Yeah, it would definitely light up your brain. Butterfinger bar.
Well, that is,
Yeah,
but he said, but
give you energy. Yes.
that,
But then you crash on the other side of it. As long as you,
Yeah, if you want a child to follow what you do, you give them something that's sweet. You give them cookies, you give them candies, you give them treats. They'll follow you like
this
Pavlov's
was
stuff.
or taking the SAT.
That's why the first 50 questions of your SAT were good, and then from there.
Yeah. So they put sugar water in a newborn baby's mouth to do a circumcision because it actually will quell the baby, it'll soothe the baby. Little sugar water. So it has a dopamine surge and a little bit of a pain relief thing. Yeah. Snickers, yeah. That stuff. Now I had a patient too that I mentioned it in one of the other classes that was never even saw me as a patient, never came to any of our classes, just used the website. So the physician down the hall from me referred this patient with diabetes, was on insulin, tons of medications, blood pressure medicine, cholesterol medicine, the whole shebang. A1C was 13.4%, really high, even on insulin, just out of control. She just utilized the website, watched some of the class recordings, went on a whole food plant-based diet. She did it 100% completely. 6 months, this is all secondhand through the physician that sent her patient there. And then 6 months later was off all of her medications, including insulin. A1C was like 5.4% normal, was off everything, and just from the diet change. Yeah. So it can be dramatic sometimes. It can be slow, it can be quick. For her, it was 6 months, but I've had patients that, and I've said earlier, I mean, not to be doom and gloom, but I've had patients that completely reversed, put their diabetes in remission, is the official American College of Lifestyle Medicine we don't say cure, because if you went back to your old diet lifestyle, it'll just come right back, right? And so it's diabetes in remission. So I had patients that completely put their diabetes in remission, got off all their medications. And then I saw them, a year later or something, and they're back on all their medications. So a lot of times I did consults for other providers, so they weren't something I was following over time, but then they came back to me, had to go back on all the insulin, all their medications, because they didn't have support at home, or just stopped eating. Yeah, stopped eating, just went back to their old diet. And so it just comes right back. And that's why we do these classes, so to give ongoing support, so you can come every week and get support. Yeah.
Understand why this has been such well kept
Yeah.
secret,
Yeah.
or why the medical
Yeah.
hasn't not that. It's not like
Yeah, we could talk. I could talk an hour on that one question. So yeah, I'll repeat the reason. And why isn't this more well known? Because the carbohydrate centric model has been present for decades.
Yeah.
And so it's just a matter of, it's our culture. It's just the normal way we eat. It's just like Gregor says, smoking was normal in the 60s. So the average person smoked a half a pack a day. Smoking was normal, just like eating the standard American diet is normal today. And so, yeah, the technology, even though we had the study in 1928 and all that, the MR spectroscopes and stuff, that's fairly new in the last decade or so. So we didn't know about this intracellular lipid until the last maybe 10 or 15 years. And what we've learned in medicine too, the way we were trained in medicine, is that it can take 40, 50 years sometimes for new science to actually make it into the standard of care for guidelines. It's the medical model is just so slow and antiquated to try to get things shifted, to try to get, we get new evidence, and then to try to get that to become a normal thing. And it just takes a long time. And hopefully someday we'll get to that where this will be just like kind of common knowledge, but we're not there yet.
yeah, this thing comes out like
A new drug. Yeah, because if there's money to be made off it, it'll go on the hyper speed.
Yeah.
If there's a pharmaceutical or some technology that can be profited, but no one's profiting off of broccoli and beans and potatoes, right? And so it's just not going to be, all the drugs, Ozempic, and then we don't even know that we don't have long-term data if they're even safe, so it's kind of taking a risk. Yeah.
Really quick, and you both can verify this,
Yeah.
I think, from what I understand, most physicians are not nutritionists. They're not.
Yeah, well,
they're not
physicians
taught- they're not-
physicians don't have any education in nutrition.
Right,
That's the
not-
thing.
I think they do.
Right, exactly. So they're
2 hours.
getting, you're not getting good advice if you're asking your provider what they recommend. Yeah, if let's say you went and got board certified in lifestyle medicine or became a dietitian, and even dietitian's education has some influence, and we've talked about, just like our education was influenced by pharmaceutical companies, dietitians' education is influenced by the food industry. So it's not, you have to kind of take that into context.
would be more knowledgeable.
Yeah.
$1.
And then you go on the American Diabetes Association's website, and their recipes recommend dairy
Yeah,
and all the stuff, because they get money from those organizations. So
There are some registered
Yeah.
dietitians, the younger ones, that do understand
yes.
whole food, plant-based lifestyle.
Yeah, there's like one of the biggest, most packed at the American, it's now the American College of Nutrition and Dietetics, their national conferences. Some of the dietitians we follow, like Brenda Davis from Canada, for example, when she speaks, she's written tons of books, and when she speaks at these big national conferences for dietitians, her lectures are just packed out the door. I mean, it's growing. It's really because there's more and more dietitians now. They're more just following the science a little bit better and more plant centric, even if they're not completely vegan or anything. Well, food pyramid is political. So we have the scientific community that says, oh, we should be plant-based diet predominantly. And then once the food industries, the lobbyists, when it goes through the process of government, it gets torn to shreds. That's the problem. So that's our problem. But yeah.
If you're eating enough calories, are you getting enough protein?
You're getting enough protein if you eat enough calories. That was the question. But yeah, I think we need to go, but yes. Yeah, if you're eating, we've always talked about that in the classes. If you're eating enough calories, you'll always get enough protein. So, yeah. You don't need protein powders. If you're a weightlifter, maybe you need maybe some extra if you're building a lot of muscle, but it could be plant-based. It could be pea protein or hemp protein, or doesn't have to be animal-based. Because there's plenty of vegans, bodybuilders, and things like that. So watch the Game Changers. Yeah. Yeah, watch the Game Changers. Yeah.
Quick final note, I come across some people that feel like they're doomed by their genetics. Both sides of my family, obesity, heart disease, heart attacks, chronologically, I have outlived my father, my grandfather, and my great grandfather. That's my genes.
Yeah.
I'm my diet.
Yeah. So
Yeah.
we say the genes load the gun, the diet and lifestyle pull the trigger. So you could have a loaded gun, but our lifestyle is what determines whether the trigger gets pulled. So, yeah. Thanks everyone. Next week is heart disease.
That was amazing.